So hello everyone. So in this lecture we are going to see that show that square of any positive integer is either of the form 3m or 3m plus 1. So here they have said that we have to find positive integer, that means n. So let us consider let n be any positive integer. Then what they have said, 3m or 3m plus 1. So look, here they have given a hint, that is 3m. That means the divisor is 3. So in the first time we have taken let n be an arbitrary element, arbitrary integer. It's better to say integer. Let n be an arbitrary integer. Then on dividing n by 3, let q be the, one second, I did 3, okay, we can say q. Let q be the quotient and r be the remainder, where 0 less than equal to r less than equal to 3, because it is always less than the divisor, and already given in the lemma. So let n be any arbitrary element, arbitrary integer. Since n is arbitrary integer, and if we divide n by 3, then n equal to 3 into, what is it, q plus 1, where q is equal to 0, 1, 2. Now what they say, so the square of any positive integer means square of any positive integer, and we have taken the integer as n, positive integer as n, so square of positive integer means n square. So 3q plus 1 whole square. This is nothing, just 9q square plus 6q plus 1. Okay. Now after doing this one, 3 cases arises by putting r equal to 0, putting r equal to 1, and putting r equal to 2. Okay. So let's say case 1. If you put r is equal, if you put q is, what is the q? No, so they have done something wrong. So everyone, actually I have done a small mistake, that is, it will be r. So it will be 3q plus r whole square, that means 9q square 6qr plus r square. Now put r is equal to 0. This one, put r is equal to 0. If you put r is equal to 0, then what is the case 1? 9q square plus, this one cancel out because 0 plus 0, because r is equal to 0. Now we can write this one as 3 into 3q square, where 3m, where m is this one. So any positive integer is either of the form 3q, 3m or 3m plus 1. So the first one is 3m. Okay. Now case 2. If you put r is equal to 1, then n square equal to 9q square plus 6q plus 1. Okay. If you take 3 common from the first two terms, that means 3q square plus 2q. Let the plus 1 be in the separate out of the bracket. Now we can write this one as 3m plus 1, where m is equal to 3q square plus 2q. So case 2, when r is equal to 1, we can say that 3m plus 1. So again this one came. Now this another one for r is equal to 2. So in case 3, put r is equal to 2. On putting r is equal to 2, what will get? 9q square plus r equal to 12q plus 4. Now take 3 common. It means 3q square plus 4q plus, we can write 4 as 3 plus 1. So we can write 4 as 3 plus 1. Let 1 remain outside the bracket, and if we take 3 common, it will be 1. So it will be 3m plus 1. Okay. So this came as 3m plus 1. So actually what you have to do is take m and find the n, then find what you will put as remainder. Here 0, 1, 2. If it is of, if they said 4, then 0, 1, 2, 3. It can be anything. But keep in mind what they have said. 3, 4. Actually this is the divisor. You have to check this one. Then you have to do a square. They may say in place of this one, they may say cube. They may say any power. But in class I am square or cube. Okay. So do the square this one. Then take common. If they have said 3, so take 3 common. If they have said 4, then take 4 common. Whatever they say, take that value common. Okay. Then you will find the required answer. Okay. Now let's answer question. Now there is another question. Any odd integer is of the form 4q plus 1. Okay. So how will you do it? Since they have said 4q plus 1, so it's better to, so let's do it. Since they have given 4q plus 1, so we can take the divisor as 4. So let's try this one. Now let n be any positive integer. Okay. Then on dividing n by 4, we will get, let's say m be the quotient and r be the remainder, where r is equal to 0, 1, 2, 3, because from this one 0 less than equal to r less than 4. Okay. So what are the cases we may arise? If you put r equal to 0, 1, 2, is 4m plus 1, 4m plus 2, 4m plus 3. But the main fact or main noticing thing is that any odd integer, actually n has 4, actually there is 4 types, but out of this 4 types, this one and this one is only odd. 4m and 4m plus 2, these two are even, because 4m and 4m plus 2 both are divisible by 2. So these two are even. Only 4m plus 1 and 4m plus 3 is not divisible by 2. This means these are odd. So we will work with 4m plus 1 and 4m plus 3. So n equal to 4m plus 1, 4m plus 3. We will work with only these two. Now what they show that square of any odd integer. So we have to do the square of this one. So n square equal to 16m square plus 8m plus 1. We are doing this one. Okay. So take 4 common. Then 4m square plus 2m plus 1. Okay. So 4 is equal to, take this one as q plus 1. Where q is equal to 4m square plus 12. Okay. Similarly, 4m plus 3. If you do this one, n equal to 4m plus 3. m square equal to 16m square 24m plus 9. So if you take, what you have to take? 4s common. So if you take 4 common, then 4m square plus 6m plus, what you can write 9? We can write 9 as 8 plus 1. So if you keep 1 outside the bracket and take 8 inside, and if you take 4 common again, then what will remain? Only 2. Then 4q plus 1, where q is 4m square plus 6m plus 2. So this is q. So we have so differ. So show that any odd integer is in the form of 4q plus 1 for some q. So we have shown. But actually you must remember this one. We have to check with the smallest possible integer. Okay. What they say? Any odd integer is in the form of 12, but the smallest form of representing odd integer is 2m plus 1, because for proving anything even, the minimum we need 2m, and if we add plus 1, then it will become odd. So minimum something that is odd is 2m plus 1. So let's try with this one. Okay. So let n be any positive integer. Then if we divide n by 2, we will get m as quotient and remainder. But since we need odd integer, so if we put r is equal to 0, it will be even. If we put r is equal to 2, not 2, Yeah, if you put r equal to 2, it will be also even. But if you put r is equal to 1, then only it will be even. No, we can put 2 because we are dividing with 2, so we can put 2. Okay. So if you square both sides, square equal to 4m square plus 4m plus 1. So if you take 4 common, then m square plus m plus 1, which is 4q plus 1. So listen, if you do this one by 2, then also it is correct. If you do this one with 4, then also it is correct. So depending on the mark given, depending on the mark allotted to that question, you just do. If they have given small mark or little mark, so try to do it as much small as you can. And if it is given with bigger mark, then you can show the bigger one like 4. There are many problems like 9, 6, 3. So first try to attend this one with the smallest possible integer. Okay, this will make the problem more easier. And detailed solution is this one.